Alright my friend, today we're gonna solve another problem from the project Euler. This time we have to find the largest palindrome made from the product of two 3-digit numbers. First of all, we have to understand what is a palindrome. So I'm gonna prompt my ChatGPT with this. Explain me what is a palindrome with different examples, and then what is the etymology of the word. Enter. So a palindrome is a word, phrase, number, or sequence of characters that reads the same way forwards and backward. Here you have some examples. For example, level. You can read level even backwards, as you can see. Rather, madam. You also have entire phrases. Palindrome comes from Greek palin, meaning again, and dromos, way, direction. Basically, the word means running back again. Cool. Here we have an example. We have this value, which is a palindrome, which is the product of 2-digit numbers, specifically 91 and 99. All right, cool. We have all the elements to write our code. Let's jump to the terminal. So I open my terminal, command space, iter, boom. And as always, I go inside my directory, which is desktop and project, no, Euler project, Euler tab, enter. ls make directory, problem 4 and cd problem 4, enter. All right, I'm inside my directory. Now here I'm gonna write my code. So we start with C, vim main.c. So I'm just gonna copy the task, comment it, then the usual inclusion of the standard input-output header file, and then the function main. Cool. So the idea is fairly simple. I have two 3-digit numbers. Basically, we go from 100 to 999, right? I have to multiply in a brute forcefully way these two numbers and get the biggest palindrome result. So I'm gonna need a function that is returning me a Boolean result. Is this number a palindrome or not? All right, here at the top of my code, I'm gonna declare two constants, which are define start and the number, which is 100. The minimum number, which contains 3 digits, another define, which is the stop constant with the value 1000. All right, so I need all the integers in between 100 and 1000. Of course, 1000 is not included. So here in my main, I need the two numbers, the two variables that I'm gonna modify, that I'm gonna multiply together. So I have int mbr1 and int mbr2. Semicolon. Okay, these are the two variables that I'm gonna process inside this code. mbr1 is equal to what to start, and mbr2 is gonna be a value that at every iteration is gonna be refreshed to 100. So I need a nested loop here. I'm gonna use a while loop. So look carefully. This is gonna be the boilerplate of a nested while loop. I say while. What is the Boolean condition of the stopping? Well, while mbr1 is minor and not minor equal to stop, right? Which is 1000. So until the number is maximum 999, what do? Ask open. I'm gonna make the other while loop here. Say while mbr2 is minor again than stop. Cool. And here I have the two curly braces of the nested while loop. So the first mbr1 is equal to start initially, right? Is equal to 100. Now, every time I want to increase this value, at the bottom of the external while loop, I'm going to write plus plus mbr1, okay? Cool. So we're going to go from 100, 101, 102, and so forth, till 999. On the contrary, every time I want that mbr2 as the value of what? Start. So every time the value of mbr2 is going to be refreshed to the value of the beginning. Of course, this is not optimized. There are operations that are going to be repeated, but that's not the point. We just want to find the result of this riddle. Then inside this while loop, what do I need? Well, I need to check if the result of the multiplication between mbr1 and mbr2 is a palindrome value, okay? So I say if is palindrome, which is a function that we're going to implement immediately. The input is going to be mbr1 per mbr2. We have to stock it. We have to say in a variable because we have to check all the possible palindromes, which are the result of the multiplication of 3-digit numbers. So we need the variable here, which is another int. It can be best match. okay? And of course, we initialize best matched with 0, because we have always to initialize a variable in C. Otherwise, there may be some junk value. So the condition is that if the result of this operation is a palindrome, and the result, again, so MBR per MBR2 is major than best match, okay? So here, as you can see, we can optimize a little bit. We have 2 times the same operation. So we can say here upstairs, say int result, okay? And every time here we just say results equal MBR1 per MBR2, semicolon. So here we're gonna write immediately result and the same here. Maybe writing in this fashion is gonna be more understandable, more readable, and overall is gonna be faster because we have to implement this multiplication only one time, right? This is a principle that is called dry. That basically means don't repeat yourself. This is a principle of software development. And here is where it is applied, because we don't want to repeat 2 times this operation. Of course, this is a silly example. An operation like multiplication is going to be super fast for a computer. Nonetheless, you understand the principle, you understand the idea. Here we can also write in this fashion. I really like to go on the next line. When I have a Boolean expression inside an if, because I can see immediately which are the conditions. So I have, if the number is palindrome and the number is major than the best match available, initially is going to be 0. What do? Well, we are going to simply say best match is equal to the result, right? Semicolon. Easy. All right, I think we are almost ready, right? With the main function. We have a nested while loop. Every time number 2 is gonna refresh to the start. And here, as you can see, we just need to increase number 2, right? So plus number 2. Okay, now we need, of course, to implement the isPalindrome function. So we're gonna go here, just above the main function. And we're gonna write this function isPalindrome. Of course, we're gonna use booleans, so we are gonna include the standard boolean header file, so we can access boolean false and true values. Otherwise, we can simply use 0 for falsehood and all the other values for truth. It's exactly the same, but I guess this is more readable. So I have bool isPalindrome, the name of the function, which takes as an input an integer that we call n. All right, then we're gonna implement the function. So how do we tackle this problem? How do we get a boolean from a number? Well, basically we have to reverse the number, and if it is exactly like the number itself, we have a palindrome. So here I'm gonna show you how we can reverse a number in C very easily. I'm gonna declare immediately a number that I call reverse, and then I have to save the number input inside a temporary variable that I call tmp. Okay? Reverse, of course, is gonna be assign the value 0 as always, while tmp is equal to n, because I need this value. You will see why. Now for this little code, for this little algorithm, we're going to exploit division and modulo operators. Here I have a few slides that really simplify the understanding of division and the modulo operation, even though these are simple concepts. As you can see, when you have division, for example, the number 1492 divided by 1000, it's like you are cutting the last 3 digits, right? You're throwing in the bin the last 3 digits. Because of course in C, when we have division, we have also truncation. So when I have, for example, 1492 divided by 10, I get 149. I throw in the bin the number 2. All right, so divided by 10, I throw in the bin one number, divided by 100, I throw in the bin 2 numbers, divided by 1000, I throw in the bin 3 numbers. Okay, so when I have division, I throw in the bin as zeros, as the zeros which are in the division. You can understand division in this fashion. I think it's pretty easy to grasp. So division is like a scissor. On the contrary, when I have the modulo operator, as you perfectly know, the modulo operator is taking the remainder of a division. When I have 1492 modulo 1000, I get as a value the 3 last digits. Indeed, I get 492. Modulo 100, I get 92, while with 1492 modulo 10, I get the 2. Exactly the remainder. Easy peasy. So as you can see, the division and the modulo are basically 2 arithmetical scissors. You can perceive like that. Of course, the story of taking the last value is modulo dependent. For example, here I have the modulo operation with a binary value. To get the last digit of a binary number, I have to make modulo 2. and not modulo 10. We make modulo 10 when we have a decimal value, but this is obvious, right? So how in our code we can exploit these operators? Very simply, we take every time the last digit of the number, and then we put it in the first place. Let's understand this idea better. I'm gonna use a while loop, and I say, while tmp is major than 0. So as you perfectly know, I can basically skip this major 0, but I'm gonna leave it for clarity. All right, ask open the braces. And then I say, I have my reverse integer in which I'm gonna stock the number in reverse. So I say reverse is equal to what? Well, reverse is gonna be equal to the last digit of my temporary variable, which is equal to n. So I say tmp modulo 10. So as you can see from the slide, modulo 10 is taking the last digit, easy. But now let's leave it like that. You will see there is a bug, but you will understand while we are coding. Okay, semicolon. Now I can throw in the bin, right? The last digit, because it is already inside the reverse. So I say tmp divided equal 10, semicolon. As you can see, the operation is throwing in the bin the last digit that now we have with us, okay? So here, as you can see, it cannot work, right? Because every time I'm gonna take the last value of my temporary variable, that every time is gonna be cut at the last position, the last digit is gonna be thrown in the bin. Basically, every time reverse is gonna take the last value, so this ain't work. The reverse at the end of this loop is gonna be just the first digit of my input. So first of all, here I need to make a plus equal, right? Every time I want to add the last digit, but once I had the last digit, what do I have to do? Well, I have to shift one position, right? Every time, at every iteration, I have to take the number and shift one position on the left. Take the number, shift on one position on the left. Take the number, shift one position on the left, and so forth, until temporary is major than 0. So to perform the shift operation, what I have to do, here, let's make more simple. Just say reverse per what? We have a decimal number, right? Base 10. So I have to make per 10. You know perfectly well, if you multiply a number per 10, you have a shift. 2 per 10 is going to be 20. Per 10, 200, and so forth. So this is basically a shift operation. Reverse per 10 plus temporary modulo 10. And this is correct. So this is going to be like a shift one position. And this is going to be digit I want to shift. Okay, want to shift. So the algorithm basically is taking all the time the last number of my temporary digit, and then it's going to shift one position. Initially, it's not going to shift anything because I have the 0 as a value. So reverse per 10 is going to be 0 plus temporary modulo 10. Let's pretend we have the number 42. At the first iteration here, I'm going to have 2. So reverse is equal to 2. Then I say temporary divided equal 10. It, of course, is like saying temporary is equal to temporary divided by 10, right? That's the same operation, but to make it faster and cooler, we do that. So 42 divided by 10 is going to be 4. Is 4 major than 0? Yeah, of course. So reverse this time, what is the value that it's going to get? It's going to get reverse per 10. So the 2 is going to shift one position. I have the number 20 plus temporary modulo 10. What is the result? It's going to be 4. All right. So 20 plus 4, 24. And it is exactly the number in reverse, as you see, right? Cool. Now we have to return a Boolean, right? We have to return a Boolean. So we are going to do return what? Reverse is equal to what? To n. This, as you can see, it's a Boolean expression that is going to return true or false if the two numbers are equal, right? And I guess that's it for my palindrome function. What do you think? All right. I don't see any potential issues. The loop is going to end because I'm going to increase the two variables. So we're just going to compile a launch and let's see if it works. So as usual, gcc main.c, and then we're going to, of course, then we're going to launch, but I forgot to put some printf to show all the calculation. All right. So we go at the bottom and we say printf, the result of the riddle is %d, and we say best match, right? ZZ to exit. I'm gonna compile and then launch. So the result of the riddle is gonna be this number. We're gonna copy it. So we passed this value. As you can see, this is a palindrome because you can read in reverse and it's gonna be the same. Check. All right, that was the solution for our problem. Easy. Now, some observations about the code. This is far to be optimized because we have to brute forcefully check for every operation. And of course, there is some mathematical trick that you can do to improve this. And here you can see the power of the define constants, because at the top we have this constant that we can easily change. And for example, we can say 10 to 1000 bigger value. This is going to be a long code because, I repeat to you, this algorithm is not very much optimized. It's gonna, as you can see, it's gonna take much more time. It has to perform all the operations, and this is far from being good. But anyway, this is the result. As you can see, this is a palindrome. So declaring two constant at the top makes the code very easy to change, very easy to manipulate, and it's fairly good, right? Now, I leave you the riddle of making the algorithm much faster when we have bigger inputs. And I think that's it. We're going to do the solution also in Python. The constraint for Python is going to be that I want to do this only in one line. So main.py. I'm going to use, of course, generators, which are super useful in Python. So here I just asked ChatGPT, explain generator expressions in Python easily. A generator expression in Python is a concise way to create a generator object, which is a special kind of iterable that generates its values on the fly. This is the big idea of generators, rather than generating and storing all the values in memory at once like a list. This, as you can see, is an example of a generator. Is going to exploit the range function that we're going to see. So this generator expression generates the sequence of each number in the range of 0 to 4. Basically, range is going to give me back all the values from 0 to 4 as expressed. And this is what I want. I want all the values squared. And all the values that are going to be generated from this generator are not going to be stored in memory. So check for generator expressions in Python. Now we're going to write one generator. I'm going to open the braces to declare a generator. And I say for I in range from 100 to 1000, right? Because range is going to give me back only till 999. So it's going to be the upper range minus 1. Now I want here to have a nested loop, so I'm going to do for I, and going to be j in range, again, 100 and 1000, right? The same idea. It's like the while loops in the C program. What do I want from these nested loops? Well, I want a multiplication of the two, right? I'm going to have I per j is what I want from this nested loop. So the generator is going to take all the values in those ranges and is going to multiply them, basically. Now, here I don't want all the values, but I want only the palindromes, right? So I need a filter, and we can do that in generators. Here at the bottom of the line, I say, all right, give me I per j, cool, the result of these two nested loops, if what? If I per j is a palindrome, right? So in Python, we have a very fast way to compare two integer values, very simply by converting the integer into a string, and then we just compare the strings. This is feasible in Python. So I say, if str, this is a typecast, I per j, right, is equal to what? Is equal to, now I need to invert the value, right? So again, here I say str, I per j, but here I don't want the same value as before. I want a slice of it. So I can use the slice operator, which is this one. And here I can do this fabulous trick, which is -1, as you can see here. This is a fancy way of saying, give me the string in reverse, right? So you have to check for the slice operator. So here I say, if I per j converted to a string, so here I have a value, is equal to the same I per j converted to a string, but in reverse this time. Basically, here is a fancy way of saying if that value is a palindrome. So here is written in the Python language, give me I per j coming from these two nested for loops, if that result is a palindrome. Okay, cool. Now I need the maximum, right, of these values that are going to be generated by this generator. So I simply call the function max. So max is a function that is returning the maximum value of an iterable, like this object. So basically now I only have to print all of this. So I say print max and all these big boy. Okay, close braces. I think we are okay with that. I think that's almost it. Let's try to launch and let's find some bugs. So we're gonna call python3 main.py, and as you can see, the result is the same. Okay, that's correct. Now, 3 big ideas here from Python. Generators, these big objects that are gonna generate values that are not gonna be stocked in memory, so this is highly performant. This is basically the syntax of generator that you have to understand, but it's fairly simple, right? Then here you have the slice operator. This is another idea that you can understand better. And this basically you have the functions which are built in Python. You go in this website, Woo3 schools, and you have all the functions that you can use. For example, the built-in function max probably is going to be here. Here it comes. You have the min and the max. Return the largest item in an iterable. Of course, you have also the min. So it's fairly easy, right? You have max between 5 and 10. And as you can see, you have 10 as a result. Easy peasy. The cooler function is range, of course. That is going to give you back a range of values that you saw. For example, x range 6 is going to create an iterable with all the values from 0 to 5. Easy peasy. And at the end, you just have to understand the slice operator. As you can see, the slice operator in Python can be used to reverse a sequence, such as a string, like we had, or a list. We cannot do that with numbers, right? That's why we have to change an integer to a string. But it's very easy with the typecasting. So as you can see here, you have your string, reverse string, you just do this slice operation, and you have the string in reverse. Easy peasy, right? That's the idea. So that's the knowledge you gained with this. Cool, we are done. Thank you for watching, my friend.